I'm currently in my hotel room in Wuhan, where I'm visiting a university. It's been a very, very long trip, and I'm very much looking forward to getting back in a few days' time, even though apparently it's freezing cold in Leeds. So this is part two of Where is Colour? So if you haven't watched part one yet, I strongly urge you to do that before watching this one. In part one, I outlined some of the philosophical ideas around whether colour is a property of the world or whether it's a perception. And in part two, I now want to be a bit more practical. I'm going to consider whether colour is a property of objects, lights, or the brain. And for each, I'll give you some of the strengths and weaknesses of the arguments. At the end, I'll tell you what I think. So first of all, is colour the property of objects? There are two main arguments in support of this. Firstly, it certainly seems as if things are coloured. When we say the ball is red, it's because it really looks as though the ball is red. And I'm sure that a few of you are thinking, what are you even talking about, Steve? Of course it's red. The second argument is around spectral reflectance and something called colour constancy. We can define objects through their spectral reflectance properties. On the screen you can see the reflectance of a typical yellow material. The spectral reflectance shows the proportion or percent of light reflected by the object at each wavelength. Now when we look at this object under different light sources, because the light sources contain different amounts of light at each wavelength, the light actually reflected by the object changes, even though its spectral reflectance doesn't. That's a property of the object. And so we might expect the colour to change, that the object would look reddish under a redder light source and bluish under a bluer light source. But that's not really what happens. Objects retain their approximate daylight appearance under different light sources, and that is called colour constancy. So people who think that objects really are coloured tend to think that the spectral reflectance of the object defines its colour. And computer scientists often view the problem of colour vision as the problem of how the visual system can recover the spectral reflectance of an object from the cone responses. So the eye's cone responses for an object do vary with the light source, but the colour remains approximately constant. So if the visual system could recover the spectral reflectance, it would explain why the colour doesn't change. That essentially is the argument. So what are the counter arguments? Well, people argue that it's an illusion, that it seems as though colour is the property of an object, albeit a very convincing one. So in evolutionary terms, it's important that we get the strong impression that objects are coloured. On the other hand, when you touch a very hot object and you feel pain, heat is the physical property and pain is the perceptual property. But if it felt to us that the pain was a property of the object, we might just hold the object and stare at it absent-mindedly as our skin is damaged. It's vital that we have the impression that it is us experiencing the pain, so that we quickly drop the hot object before it harms us. But for colour, it's the opposite. It's important that it seems as though colour is the property of objects, so that we can use colour to infer what is happening. For example, whether this or that fruit is ripe. and act accordingly. And in terms of colour constancy, although objects do retain their approximate colour when viewed under different light sources, there is some variability in the colour. That is, colour constancy is not perfect. And so that is hard to reconcile with the idea that objects have a fixed colour. And it breaks down completely when we have extreme changes in light sources. In these pictures of me in the lab, for example, you can see the colours of the jumper I'm wearing changing as we change the colour of the lighting in the lab. But more importantly, colour constancy is just one of many colour phenomena. There's also contrast, which tells quite a different story. So imagine the two colours you can see on the screen are two pieces of card or plastic, and they have identical spectral reflectance properties, and they look the same. But now we put them on two different backgrounds, and they no longer look the same colour, even though they have the same spectral reflectance as before. All in all, I think there's more evidence that spectral reflectance is not equated with colour than evidence that it is. Honestly, I think we can discount the idea that colour is the property of an object. So now we can turn to the idea that light itself is coloured. Objects look red because they reflect red light. The arguments in favour are similar to before. Again, if you see short wavelength light and it looks blue, and you see long wavelength light and it looks red, it certainly feels as though the light really is blue and really is red. But the idea that light is coloured is strongly linked to the idea that we can associate different wavelengths of light with different colours. So light at about 680 nanometers is red, and light at about 580 nanometers is yellow, for example. But the biggest problem with this is that we can see many colours in the world, about 3 to 5 million in my opinion, and yet only a few of them can be seen in the spectrum and are associated with single wavelengths. Most notably, purple and magenta are not in the spectrum and can only be seen when we see short wavelength light and long wavelength light at the same time. Does this mean that magenta is not real? It seems really difficult to me if we're going to say that some colours such as red and yellow are real because they correspond to certain wavelengths, and other colours such as purple and magenta are imaginary or illusory in some way. Well, that's exactly what a recent BBC video implied. It's called Magenta, the colour that doesn't exist. I do not like it at all, but I've put a link to it in the description. Please watch it and make your own mind up. The problem is that it certainly doesn't seem like there are two sets of colours. Some that are real and some that are not. Surely either they are all real or all perceptual. And then we have the problem of additive colour mixing. If we overlap single wavelength red and green light, where we see the additive mixture, we experience yellow. So let's say red is 680 nanometers and green is 500, and yellow is this narrow band between 560 and 590. Where we see the additive mixture, which is just the red and green light being coincident in space, overlapped, we don't have any yellow light, that is, light in the range 560 to 590 nanometers. So are we saying that the yellow we see when we see single wavelength light at 580 is somehow real yellow, and the yellow that we see when we see the combination of lights at 500 and 680 nanometers is somehow not real? Well, there's a video on YouTube called This Is Not Yellow, again, link in the description, that tries to make this claim. In this video, Michael Stevens tries to claim that the yellow that we see when we look at a real lemon is real yellow because the lemon reflects a narrow range of yellow wavelengths. But the yellow we see on a computer screen is fake yellow because there is no actual yellow light emitted by the screen. So I wrote a paper, again, link in the description. I'll always try to link to things when I'm using them as evidence to make a particular point. Anyway, in this paper, I provide a rebuttal to the YouTube video I've just mentioned. Michael makes two serious errors. First, computer screens do emit yellow light. Even though they emit light that looks red, looks green, and looks blue, the RGB primaries, this doesn't tell us which wavelengths are being emitted. If we measure the wavelengths emitted by the red and green primaries, and I did this in my paper, they both include light in the range 560 to 590 nanometers, so displays do emit yellow wavelengths. The second error is to assume that a yellow lemon, for example, only reflects light in the very narrow range 560 to 590 nanometers and absorbs completely at the other wavelengths. This is completely untrue. Recall the reflectance of a typical yellow object I showed earlier. Not only is it not the case that only the yellow wavelengths are reflected, but it's not even the case that the yellow wavelengths are the ones that are most reflected, which should make you think, why does it look yellow? So when you look around you at your walls, carpets, clothes, hair, skin, etc., all of these things reflect all of the visible wavelengths to some extent, though obviously each may reflect some wavelengths more than others. And we see colours as a result of the additive process. When do we see individual wavelengths? Actually, only in a couple of very specific and unusual circumstances. When we see a rainbow, when we pass light through a prism, like Newton did, and when we see lasers, perhaps. Everything else is the additive mixture of many wavelengths. So if we're going to claim that we only see real colours when we see individual wavelengths, and that the colours that result from seeing mixtures of wavelengths are illusions, then we have to conclude that almost all of the colours that we see are illusory, apart from a small few, and this doesn't make any sense at all. For me, the evidence that light is not coloured is even stronger than the evidence that objects are not coloured. So finally, we have the idea that colour is a perception and that it really only exists in your head. The argument against, well, it's completely counterintuitive. It's not what colour perception feels like, as I mentioned before. However, we have a reasonable understanding of human physiology that seems to provide mechanisms for why phenomena such as colour constancy and colour contrast occur. However, an important piece of information to support colour as a perception is the variability in colour vision that we know exists. People who are so-called colourblind, technically we should say colour deficient, and we'll cover that in a later video, of course. they see the world differently. They see different colours. We know this because two spectrally different objects in the world might look quite different to you and I, but someone who is red-green colourblind may be unable to tell them apart. Now, some may argue that the two objects really are different in colour, but someone who's colourblind just doesn't have the wetware, if you like, to see the world properly. However, there's also the observation that even people with normal colour vision will disagree about whether two colours match or not. And that's because of several variabilities. The distribution of L, M and S cones in the retina varies from person to person, just like we vary in height from person to person. We also have a yellow pigment in our eyes which protects our cones from dangerous short wavelengths of light. And the amount of this yellow pigment, called macular pigment, varies from person to person and also varies with age. And finally, we wonder what the world looks like to whales who only have one type of cone and probably only see shades of grey, or to goldfish who have 5 different types of cones. So a goldfish might see two colours as being different when we might see them as being the same because we only have 3 cone types. In short, if the world, whether we mean objects or light, really is coloured, but it looks different to all of these people and to all of these different species, then which one species or which individual is seeing the truth? Again, it just doesn't add up. And therefore we have to conclude that there is no objective truth and that colour is subjective. For me, having worked in this area for 43 years now and counting, the only position that makes sense to me is that colour, like taste, like sound, like smell, is a perception, and that without living sentient creatures in the world, there would be no colour, only atoms and the void. Now, some of you might think I'm still being too philosophical and that back on planet Earth, rather than in academia, things that look red really are red. But I've been in many situations where it's important to understand that things are not coloured. And I'm going to give you one example. About 20 years ago, I was asked to be an expert witness for the police in a murder inquiry. Basically, a person was murdered in London. There was a witness who had left the country, but they had left a statement that identified the murderer. The problem was they'd said that the person who was murdered was wearing a brown coat. But the defence lawyers produced the coat and it was clearly blue, or at least looked blue. And they claimed that the witness was invalid because they had obviously seen a different incident, that they couldn't have seen the murderer in question. I was asked by the police who were prosecuting whether it was possible that the blue coat could have looked brown to the witness. If I could show this, then the statement by the witness could be admitted. Of course, I was able to show it by arguing that either the witness may have been colourblind or that the street lighting may have been changed since the night of the murder. And indeed, records showed that the yellow tungsten street lighting had been replaced by bluer LED lighting since the murder. And at trial, the prosecution were successful. So as I mentioned before in the last video, I think, this was a tough question to start with, and To be honest, I have some regret that I started this series with such a heavy topic. I'm very confident in what I think, that colour is a perception. But it's not possible, in my opinion, to categorically refute the other positions. At the end of the day, until we understand the hard problem of colour, see my previous video for what I mean by that, there will always be uncertainty and some room for disagreement. So, I finally got through this very taxing question with a two-part video. And what should you be left thinking? Well, I hope you agree with my position. But more than that, I hope it's made you think about colour. It really is a complicated topic that we don't fully understand. But that, for me, is what makes studying colour so worthwhile. So next time, let's look at something a little less controversial. The question, is black a colour? And until then, bye for now.